This is Password Assistant, a browser extension that helps users create compliant passwords during account creation or reset. The problem it solves came directly from our need finding exercise, where 72% of users in our survey only saw password requirements after their password was already rejected. That's a fundamental design failure. It forces users into a trial and error loop. 33% of those users ended up settling for a weaker password just to comply. That's not just an usability issue, it's a real security consequence. The goal of this interface is simple: surface all requirements before the user starts typing and keep them visible throughout the interaction. When the extension detects a password creation field, it automatically loads the site's known requirements from a crowdsourced database. Here you can see it's loaded the requirement for suncountry.com. The green banner at the top confirms that the requirement has been successfully loaded for this site. The requirements are displayed upfront in a 2x2 card grid: length, case, symbols, and history rules, even before the user starts typing a single character. This directly implements Nielsen's recognition over recall heuristic. The user doesn't need to remember any rule, discover it through rejection, or scroll to find it. Everything is visible immediately. Now, as the user starts typing, you can see that the password pass12 in the manual entry field, the live validation panel below it updates in real time, character by character. Each requirement is independently tracked. Uppercase is satisfied, valid. History check passes, valid. But character count shows as 6 weak because we need at least 8 characters. And special character shows missing because no special character has been included yet. The non-compliant badge at the top of the validation panel summarizes the overall status at glance. This is Nielsen's visibility of system status heuristic. Precise, actionable feedback at the exact point of interaction, not after clicking submit. It also reduces cognitive load by externalizing the compliance state entirely. The user doesn't need to hold all 4 constraints in working memory simultaneously while typing. One thing worth noting about the history check: you will see a small note beneath the requirement panel: history check performed locally, no password transmitted. In a real implementation, the extension validates against password already stored in the user's local password vault. For users with Password Manager, that data is already available locally on their device. For users without one, this check would be skipped or show unable to verify. No passwords are ever transmitted. All history validations happens entirely on device. This note was added directly in response to our first evaluation, where participants specifically asked how the extension could check password history without accessing sensitive data. Finally, at the bottom of the screen, you can see the smart generator is collapsed. Users who prefer to type their own password stay entirely focused on this manual entry view without any distraction from the generator controls. That's the manual entry part. Now, let's look at the generator path. For users who prefer automation over manual composition, expanding the smart generator reveals the second interaction path, and this is where the hybrid design really comes together. At the top, the requirement panel is the same 2x2 card grid: length, case, numbers, and symbols, loaded automatically for suncountry.com. The same privacy note is present beneath it: history check performed locally, no passwords transmitted. The live verification section shows all 4 requirements as valid: character count, uppercase, special character, and history check, all green. This tells the user their password is compliant before they even touch the submit button. Now for the generator itself, the length slider is set to 14, annotated at 8 to 16 range directly next to the value. So the default value is immediately self-explanatory. This was a specific fix from our first evaluation, where participants were confused about why the slider defaulted to 14 rather than minimum or maximum. The annotation removes that ambiguity entirely. The 4 character class toggles: ABC for uppercase, ABC for lowercase, 1, 2, 3 for numbers, and the others for symbol. All are enabled to match what suncountry.com requires. The generator resolves those constraints automatically from the database entry. The user doesn't need to configure anything. The generated password is displayed in a dedicated card. Next to it are two action control buttons, a regeneration button to produce a new compliant password if the user doesn't like this one, and a clearly labeled copy to clipboard button. Both were redesigned from the low fidelity prototype based on the first evaluation feedback, where participants couldn't identify what the icons did. Labeling them by function removes that ambiguity. At the bottom, the use this password button inserts the password directly into the site's field with one click. This closes what Norman calls the gulf of execution, the gap between what the users want to accomplish and what the interface requires them to do. The user wanted a compliant password, one click delivers it. Notice that both interaction paths share the same requirements panel and the same live verification section. A user who types manually sees their password check against the same 4 requirements as a generated password. The mental model is consistent regardless of which path you take. This design directly responds to the split we saw in our first evaluation. 56% of our participants preferred the automated generator. 44% preferred the live checklist. Rather than picking one winner, this final prototype makes both available in a single unified interface. The generator is opt-in. It doesn't interrupt users who want control, but it's immediately accessible for users who want automation. Neither group has to compromise. That's the password assistant.